Defining configuration settings, part 2. 50. Shift to the third tab, sampling, and make sure the settings are exactly displayed as on the following window. 51. Set the sampling type to Latin hypercube. This setting specifies the type of sampling used during an at-risk simulation. Sampling types differ in how they draw samples from a distribution. Latin hypercube sampling, the recommended type, more accurately recreates the probability distributions specified by distribution functions. In other words, it takes fewer iterations to achieve the same accuracy when compared to a Monte Carlo sampling. 52. Leave the generator as it is predefined text of Mersenne Twister. The generator is an algorithm for generating a sequence of numbers whose properties approximate the properties of sequences of random numbers. This sequence is not truly random because it is completely determined by an initial value called the seed, which may include, as we will soon see, truly random values. At-risk comes with 8 different algorithms. Its choice belongs to higher numerical mathematical analysis. Our recommendation is to never change this parameter and just leave it as it is on at-risk's recommendation. 53. In order to guarantee reproducibility, set the seed as a fixed one on one arbitrarily chosen value. In this case, we will use 1985. The seed number itself does not have any special meaning. As long as you choose a positive integer, number smaller than 32 million, at-risk will always run the same sequence of pseudo-random numbers every time a simulation is performed. If you change the seed to a choose randomly option, then every time you generate a simulation, you will end up with slightly different results. 54. On collect distribution samples option, leave it on the all option. This setting specifies how at-risk collects random samples from input distribution functions during a simulation. All specifies that samples will be collected for all input distribution functions. In other words, at-risk will store in memory iterative information of input variables. This is the way to eventually create tornado charts. Since a tornado chart is, in essence, a chart that depicts the relationship between inputs and outputs, if this option is otherwise selected at none, then no information will be collected on input variables. Therefore, it would be impossible to draw a tornado chart. Since one important part of a final analysis is to determine the relative importance of each one of the products in our portfolio, then it is important to leave this option on all. Consider that this means an additional storing process in your simulation, thus creating a slightly lower simulation and a more crowded usage of memory. 55. On smart sensitivity analysis, leave this option enabled. By default, at-risk uses a smart sensitivity analysis. To do this, it pre-screens inputs based on their precedence and formulas for outputs. Inputs that have no direct or indirect link to an output cell are removed from the sensitivity analysis, thus avoiding spurious results. Smart sensitivity analysis is performed because it is possible for simulation data to show a correlation between an input and an output when, in reality, the input has no effect on the output in the model. Without smart sensitivity analysis, tornado graph bars could be displayed for those unrelated inputs. Since we want to analyze the relative importance of each input variable on determining total annual profit, we need to leave the smart sensitivity analysis feature on. 56. On the update statistic functions, leave it as it is on default at the end of each simulation. This option specifies when at-risk statistics functions, such as risk mean, risk target, etc., will be updated during a simulation. In most cases, statistics do not need to be updated until the end of a simulation, when you wish to view final simulation statistics in Excel. 57. Exit the simulation settings dialog with OK as we will skip all the sections on the next two tabs of macros and convergence. Running the simulation. 58. Start a simulation. This is the core element of the whole process. Everything revolves around the simulation itself. At-Risk will calculate in this case whether it is worth spending several additional seconds opening 4 parallel sessions in Excel, one for each one of the multiple processors available in our computer. Therefore, a pre-simulation dialog window appears while opening these multiple sessions. By clicking on the very last icon of the simulation progress window, you will be able to see how these are open and placed into a simulation mode. If deemed necessary, once these parallel sessions have been opened, At-Risk will allocate batches of iterations to each one of them. Notice that demo mode has been set off during simulation settings. Demo mode has to be turned off in order to allow for multiple processing. Since demo mode allows watching Excel spreadsheet and chart updates, this mode is incompatible with parallel processing.